Yo, what's up?
Hello.
Hi, how's it going?
Not bad. How about you?
Good. I'm excited to talk about abstract math. Wanted to talk
I
about
kind of
infinity.
regret that at the end, but that's
One
okay.
second, my mother-in-law is um yeah, they're gone. Okay, perfect. Yeah, so yeah, I've been watching a documentary on Netflix. Let me write it down. Let me actually connect my it was its name was A Trip to Infinity. Um Netflix. And it was about infinity from different perspectives. There was like a um, um, physicists, people from math, applied math, abstract math, and they were talking about the infinite hotel, right?
Oh, Hilbert's problem. Yeah.
Yeah. So, and then they talked about, so here's what I want to ask you, and I want your interpretation from abstract math. So, we can basically show that if this is a circle and this is a center,
Mm.
there's another circle here, the same center. You can prove that the number of um, points, there's a one-to-one correspondence, right? What it means is that the number of points in both circles are equal,
Sure. Yeah.
something like that. But yeah, I understand infinity is large, but what does that mean? Like, yeah, explain this a little bit. How it's possible?
Um. Okay. So think of it this way:
Mm-hmm.
if something is twice as big as something else,
Sorry, something is twice as big as something else. Okay.
right? You have a box,
Okay, I have a box. Okay.
and I tell you to make it twice as big.
Mm-hmm.
Then let's say, and we don't start doing paradoxes, so we double the size.
Okay, like this.
Yes. So what you're doing here is pretty straightforward because you have, let's say the side length is unit. It's like the
It's
unit
not.
measurement, so it's
Uh-huh, uh-huh,
one.
uh-huh, uh-huh.
You just double it and you make it two.
Mm-hmm.
So that sort of doubling
Yeah, doubling. Uh-huh.
makes sense when the numbers are finite, and the same applies to addition.
Mm-hmm.
When it comes to infinity,
Mm-hmm.
that doubling has so little effect that it barely changes your outcome.
I see.
Think of it when buying a car. Like you're buying a car that costs, let's say you're buying a brand new car and it costs,
Mm-hmm. Mm-hmm.
if it costs 30K and 5 cents,
Mm-hmm.
it makes zero difference to you. Even if it costs 30K and $10, it makes zero difference to you
I see.
because when you compare those $10 to the 30K,
Mm-hmm.
it's nothing. But if you're buying, let's say, flip-flops from Target and
Mm-hmm.
you have one
And
pair
one.
that costs $2 and one that
Mm-hmm.
costs 12, that is a massive difference.
Mm-hmm.
Um, so sizes are relevant, and it's actually surprising that humans have trouble grasping that because humans tend to think a lot with ratios instead of absolute.
Mm-hmm. Mm-hmm.
And that's exactly how you can think about infinity. You have that little circle, and it has so many points that even when you double it by, let's say, doubling the
Doesn't
radius,
matter.
it doesn't even
When you
register.
say it doesn't matter, you mean to us doesn't matter, right? Or
It,
like, let's say if there's a giant in somewhere else, for them it matters. I just wanna make sure it's a matter of scaling, right?
yes, so there is a scale where it will begin to matter. So there
Planck,
is this thing
Planck.
in math that
Uh-huh.
we call um, the sequence of infinity.
Sequence of infinity. What is it?
So basically, what you do is you look at all the different types or all the different ways that you can have infinitely many objects,
Mm-hmm.
and you classify them in orders of magnitude.
Oh, I
To,
see.
to make an analogy, that would be like if you're looking at finite numbers,
Mm-hmm.
classify them in orders of magnitudes with respect to powers of 10.
Mm-hmm.
Right, so you have the dozens, hundreds,
Mm-hmm. Mm-hmm.
dozens, tens. Similarly, when it comes to infinity, you have a sequence. We're actually using the letter aleph for the sequence of infinity. So we have aleph zero.
Aleph?
Yes,
Like Aleph in Farsi? Oh,
yes.
nice. Okay. Okay.
So aleph zero is the smallest
Smaller.
infinity.
Uh-huh.
And it's very special
You
because,
already, sorry, you already answered my second question. Go ahead, go ahead.
oh, what was the second question?
I wanted to talk about number of numbers between 0 and 1 and number of real numbers. Which one is bigger? Yeah.
Whoa. So aleph zero is the nicest infinity in the sense that it is the most tangible.
What is tangible?
Like it's the one that we can actually comprehend.
How? What do you mean comprehend?
Because aleph zero is the infinity of counting. You start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? You can keep going forever.
Can I
Right?
interrupt you?
Yes.
Yeah, so I don't know if you believe in God, but if I talk about it from abstract, like if I think about it from abstract math perspective, if God is infinity, we don't understand them, right? It's just
Mhm.
we're looking at shadows of infinity, or
Well, that's more philosophical than it is mathematical. So
yeah,
all
of
I
course.
say is like a personal opinion. But
Yeah, yeah, yeah. I
uh,
want to know your
my
opinion.
question would be then, what
Yeah.
kind of infinity?
Oh, okay, okay.
And
Perfect.
what do we mean by understand? Because there's
What is it?
different ways
Yeah,
of understanding what infinity is. Um,
because we can't understand it. That's the
yeah,
thing. Okay.
right. But there are ways. Okay, so I learned that theory of ordinals in Greek, so I will be trying to translate the terminology. I might be getting it wrong.
No
So
worries. Yeah, yeah. All right. If you
there
can send me some references, I can also add it just in case. But yeah,
all the references are Greek,
never
but
mind then.
there
Go
is
ahead.
this
Yeah.
concept of potential infinity. And the what that means is that you don't actually get infinity, but like if you could go forever, then that would also never end, right?
Can I? Yeah. So when we are dead forever, right?
Mm-hmm.
Okay. Yeah, that was a quote. Go ahead.
Right. So suppose that you have a person that can live forever. If they start counting, they can count for as long as they live, which is forever, and the numbers will never end.
Mm-hmm.
And that is the smallest infinity.
Yeah, nice. Uh-huh.
That is Aleph
Uh-huh.
zero. And we also call it
How
omega,
many alephs we have?
infinitely many.
Oh my God. I knew that's the answer. That's the thing that makes it complicated. It's like what's the term? Loop. It's inside.
Yeah, there's like some self-referential problems that come from saying that you have infinitely many infinities, but
I was
that,
actually reading something about religion and religious stuff. So um I think there's actually a bridge to that, like a loop theory. No, I don't know what's the word by word translation, but yeah, it was actually talking about that. You can't prove because it's a loop. Doesn't matter where you
oh
start,
yeah, that's
you go
where
back to it. Yeah.
Gödel becomes
Get
relevant.
up. Okay.
So everything that has to do with studying infinity, or I shouldn't say everything, but like most of the stuff that comes to do from studying infinity and ordinals and cardinals are deep, deep concepts in
Yeah.
set theory.
Mm-hmm.
And set theory for math is incredibly basic and incredibly complicated because it's one of the most fundamental building
Mm-hmm.
concepts.
Mm-hmm.
And once we start talking about set theory, we need to start mentioning Bertrand Russell, which had the paradox that if you have a set that contains all sets,
If you have a set that contains all possible sets, uh-huh.
does that set contain itself?
Oh my God, don't I don't think I'm gonna slip on. But there's no answer to that, right?
Yes, there's a pop culture version of that paradox, and it's the following. So let's say you have a town,
We have a town, uh-huh.
and that town has rules. And those rules are everyone who grows a beard must shave it.
I can't live there, okay? Go ahead.
Everyone, no one can shave themselves.
Mm-hmm.
Everyone must be shaved by the barber.
Okay.
If you have those three rules and you have a barber that can grow a beard, who shaves the barber?
How many people are there?
There's only one barber.
There's only one barber. So the barber can't do it by himself. So no one? But the
And
yeah.
he has a beard that he hasn't shaved. So no matter what you do, you violate the rules.
Yeah.
So you have a system of rules that creates a paradox. And that was Russell's observation about what was naive set theory. And Zermelo and Frankel created a series of new axioms, and we had this new set theory that provides a much better foundation for math.
Mm-hmm.
But that's where Gödel came into play, and
Gettle is the loop.
Kurt Gödel.
Oh, okay, okay.
He showed that math is so self-referential that if you have a theory that can prove everything, then it creates contradictions.
But is it a statement or is it a fact? What is it? You can prove
It's
that you
a
can
it's
show
a
it?
theorem. It's Gödel's incompleteness theorem.
Oh wow. And you
It
can
has
prove it?
yes, absolutely, using set theory.
Nice. The new one, right? Or
New
the old,
one.
the new one. Okay, okay.
New.
Hmm.
And that also relates to the God thing you mentioned,
Mm-hmm.
because Gödel has another proof as an exercise to mathematical logic,
Mm-hmm.
where he defines God as a being or object that contains all absolutely positive properties. And he has all these sorts of definitions about what a positive property is.
Yeah.
And he shows that within the mathematical framework, if you can classify properties as absolutely positive, then there must be a being that
Mm-hmm.
contains all positive properties. And that's Gödel's proof of a God, which is, like just a philosophical exercise, not like.
I told you, you can prove, we can prove with math, right?
Yeah.
Yeah, yeah, yeah. I mean, you're studying math, but anyway. This is two more things about infinity. I'm so excited. So, number of even numbers, number of odd numbers are equal.
Sure. This one is kind of easy to understand because you can find a way to match them one by one.
Yeah, what is a one-to-one correspondence? Is it a method to when you
You
can't
start, yeah,
count? Yeah, okay. You show that number of elements here is equal. Okay,
yeah, like
but
you map every element to its double from odds to
but
evens, and then it's
so
exact.
yeah, in like limits or integrals, epsilon goes to 0, right? And we have this approximation of integral by summing up those little, rectangles. So what's that? So what I'm getting from this 15 minutes is that those are actually not, it's a number, right? That delta is not pure zero, or is it pure zero? You know what I'm talking about?
Delta. Sorry,
Sorry, sorry.
can you repeat that? I
Yeah,
didn't.
yeah. So epsilon goes to 0, limit of something, epsilon goes to 0, right?
Mm,
Integral is a sum of some, rectangles. So those
yeah.
rectangles, what's the width for those rectangles? It's
Oh
not
yeah, yeah.
it's not 0, right?
It,
Or
it's
it is
not
0.
zero. It goes to 0.
But like what about the do you know Planck constant?
Mhm.
So
Well, you can compare the two, right? Because Planck's constant has to do with
yeah, I know, but it's about
more tangible
quantization. Yeah,
things.
yeah, yeah, yeah. No, 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 no. But what I'm saying is that concept in physics is that energy is like quantized, right? Here also, what understanding is that the scale matters, and it matters where are you looking at from, right? So you're in a different planet or you're on Earth. And based off of that, the epsilon is different, right? Am I?
When we're talking about limits, we're
Uh-huh.
in the opposite direction, right? So
Okay, cool. Okay,
infinity is infinitely big, limit is infinitely small,
can you repeat that?
right? When you take epsilon going to 0,
Mm-hmm.
that becomes infinitely small, but it never actually becomes 0, technically.
Yeah, I know. I mean, I know what you're saying, but it's hard for me to understand.
It's not you, it's like that's the normal
But
response.
we used to, like, I still am proving limits. What's the limit of this function when it
Mhm.
goes to 0? And I am using those, but
Remember limits that were more tricky. So when you had a function that was maybe 0/0, right? In those cases, what mattered is how
mhm. Oh
numerator
yeah,
would,
yeah, how, yeah, how fast you mean, or like how from like
yeah, how
direction?
fast, how slow, if it oscillates.
Oh, okay, okay.
Um, so the speed, for example,
Mm-hmm.
would sort of represent different versions of infinity.
Mm-hmm.
Um, which, okay, what I'm saying is not entirely right, but it's a way of like thinking the analogy,
Mm-hmm. Mm-hmm.
right?
Mm-hmm.
So there are infinitely many integers and there are infinitely many real numbers, but
Say
there
that
are
again. Sorry,
so
sorry. Infinitely many integers and infinitely many. When you say infinitely many, it means it's countable.
infinitely many means that they're infinite. Countable is not necessary,
Something. Oh yeah, yeah, yeah. Oh my God.
right? So integers are
Mhm.
countable, right? You can
Okay,
count,
yeah, 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 yeah. Because you can't count them. Yeah.
but reals are so many more. They're both infinite, but
Can you actually prove that there are so many more, like there are more than real numbers? I mean, I'm pretty sure you can prove it, but
mhm,
that's cool. But
it's
two more
actually
questions. Go
uh,
ahead. Go ahead. Sorry.
sorry. It's that proof is called the diagonal argument, and
Diagonal
my
argument.
opinion is one of the nicest like techniques in math, like diagonalization arguments. You
Definitely. Let me write it down. We're gonna get back to that. Diagonal.
measure theory, yeah.
Yeah. Oh my God, measures.
Sorry,
I
real.
I also wanted to take real analysis, but I was scared.
Don't
Yeah.
can't blame you for that.
Yeah, so one last question for this amazing 15-20 minutes, and then we continue later. So if you want to talk about 1/0,
Mhm.
what would you say? How do you explain it?
What kind of zero?
1/0, sorry.
What kind of zero?
You tell me, I don't know.
Well,
They told me it's you can't define 1/0. So when you say 1/2, it means you have a pizza and you want two slices out of it, right? Two equal.
Mhm.
1/10, 10 slices, you have 10 people. 1/0, you have 0 people and you're trying to give the pizza to 0 people, so it means you have infinite slices?
Uh, sure, that's one way of thinking about it. It's something that just becomes um you sort of I'm trying to figure out how to phrase it.
Yeah, check your time.
Um so 1/0 can't exist by itself, right? Because it doesn't make very much sense.
Okay.
And it doesn't make very much sense because zero is absorbing. What do I mean by that? Anything you multiply by zero becomes zero,
0. Yeah.
right?
Like what's in this space? Wormhole? No. Like that, like absorbs everything. The
Oh,
like
like a
it,
black hole.
yeah, black hole, sorry. Oh, like
Yeah,
all the
sure.
energy. Okay.
Yeah,
Uh-huh.
right. It absorbs everything. So, um, if you think about 1/2 is a number that if you multiply by 2, it becomes 1.
Mm. Oh, nice. And now if you multiply that by 0, go ahead.
Can't do that because it doesn't become 1, it becomes 0.
Nice.
Um, so you can't think of 1/0 in the limit sense. So you don't actually have 0, you have a quantity that becomes smaller and smaller and smaller and smaller.
Mm-hmm.
And that allows you to calculate 1/0 uh, based on the speed.
Oh, I see.
Small.
So you're saying there can be multiple answers based off of the way that you're approaching to 0? Or...
No, 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 no.
Okay, okay.
But it can be that there is no answer because there's oscillation.
Oh,
For
okay,
example,
okay, okay, okay.
think of the classical example in math is 1/x.
Yeah. Uh-huh.
So your gut would tell you that 1/0 should be infinity,
Mm-hmm.
right? Because 0 is so absorbing, the only way to counteract it is to multiply it by something that is equally absorbing.
Make it 1. Yeah.
Okay, so when we're talking about real numbers, there are two infinities, plus infinity and minus infinity.
Okay.
If you look at 1/x as x goes to 0,
Mm-hmm.
and you look at it from the right side, so you're 2, 1, 1/2, 1/4, blah, blah, blah. Then what do you need to quote unquote multiply 0 with to get 1?
I see. Probably infinity, right?
Right, and positive infinity, because you want it to be 1, not -1.
But if you get close to 0 from left side,
Then what do you need?
minus infinity. Probably.
So is 1/0 positive infinity or minus infinity? Because those are very different.
Yeah.
So
I
there
see.
are cases where that would not be defined because it would create that sort of paradox. But you can go around it by, say, taking absolute value of x. 1/absolute value of x is positive, is plus infinity, you're done. Or like
Perfect.
squared. That's what I mean by the speed matters.
I
Or
see.
I shouldn't say the speed, the oscillation
The
matter.
oscillation matters, definitely. Perfect, yeah. Thank you. I think it's a good place to stop right now.
Sure.
Yeah, I
Thank
really enjoyed talking
you.
today. Yeah, let's continue. Perfect. Let me pause it.